In this video, we'll look at various sampling methods and discuss possible pros and cons of these methods. So, we're considering the problem of the university, trying to get the student body's opinions about dining services. The university has already decided that it wants to do a sample, and it would like to avoid introducing bias. However, that still leaves a lot of methods available. So, what can the university do? And how might it make the decision about which method is best? So we'll consider 5 different commonly used sampling methods. 4 of these are random: a simple random sample, a systematic sample, a stratified sample, and a cluster sample. The last is non-random, a convenience sample. Let's look at each in turn. First, a simple random sample. I like to call this the names in a hat method. In this method, each individual observation in the population is given the same independent probability of being chosen for the sample. One way of doing this is just to put everybody's name on slips of paper, put them in a hat, then draw out the number you need for the sample. Now notice here, there is no attempt to put the individual members of the population into any kind of group. Rather, each stands individually and has an equal chance of being chosen. The benefit of this approach is that it is easy to understand and avoids biases that can be introduced if we intentionally group observations. However, in some cases, this can be really expensive to implement. For example, suppose I'm visiting houses in my township to administer a survey. If I use a simple random sample, I may end up driving around quite a bit of the township and back and forth across it if I didn't select the addresses first and arrange them in a reasonable driving route. A second option is a systematic sample. Here, the choice of the first sample observation is random, but each additional observation is determined systematically from that first. For example, I may randomly choose one of the first 4 houses on a street. Then I survey that house and every 4th house after that. So basically I have 4 sets of houses. I have numbers 1, 5, 9, and so on. Number 2, 6, 10, and so on. Number 3, 7, 11, and so on. And then number 4, 8, 12, and so on. So 4 different groups. And then I'm randomly selecting one of those groups. Now, since each group is equally likely to be chosen, that means that each house is also equally likely to be chosen. Now, the benefit to this is that it's often easier to implement than a simple random sample, just because you don't have to randomize as often. Now, a possible downside, though, is that it assumes that the system we use won't overlap with some kind of systematic difference in the population. For example, maybe every 4th house in a particular neighborhood has an attic, while all the others don't. This is possible, depending on the choices made by the developer that built the neighborhood. So in that case, we've accidentally introduced a bias in our sample if attic havers are different from attic not havers along whatever lines we're measuring. Now, this downside may not occur very often, but it is important to keep in mind as a possibility. A third option is a stratified sample. The idea here is to divide the population into various strata, then we sample from each stratum in such a way that we ensure that the strata are represented in the sample the same way they are in the population as a whole. Often this is used with demographic groups. For example, in the US, we know about 34% of adults have never been married. 51% are currently married, 6% are widowed and not currently married, and 9% are divorced and not currently married. So, if we were gathering a stratified sample of 100, we'd ensure that 34 of those were never married, 51 are currently married, 6 are widowed and not currently married, 9 are divorced and not currently married. So this is the benefit of this method. It ensures we don't accidentally over or underrepresent a particular group, which might be easy to do. Especially, say in this case, it'd be very easy to end up accidentally overrepresenting the married group and underrepresenting the widowed group. The challenge, though, is that this method can be difficult to implement, especially if there are some very small strata. The fourth random sample option feels somewhat similar to a stratified sample, but it's actually quite different. In some ways, it's actually the opposite. Right? So a cluster sample involves dividing the population into clusters. We then randomly select specific clusters that will be included in the sample. Now notice the difference between this and stratified sampling. With stratified sampling, we're sampling from each stratum. to ensure that every stratum is represented in the sample. With cluster sampling, we're taking a few clusters in their entirety and leaving other clusters out of the sample. For example, we might divide a city into same-sized neighborhoods, and then sample every household in each of 4 of those randomly chosen neighborhoods. The big benefit to cluster sampling is that it's often relatively low cost. In this case, we only have to walk around 4 neighborhoods rather than a random smattering of houses in a large number of neighborhoods. The problem with cluster sampling is that if the members of a particular cluster are all similar, we can end up accidentally having an unrepresentative sample in the end. So while in principle accounting students and management students might have an equal likelihood of being chosen, once we randomly select that accounting class to sample, we end up overrepresenting the accounting students. So we need to be careful to ensure that we have enough clusters and that the clusters are at least somewhat diverse internally. The last sampling method I'll mention is often researchers' favorite, a convenience sample. Convenience sampling is exactly what it sounds like. We sample based on availability. For example, when a psychology professor uses their students for research, that's a convenience sample. The big benefit is that this is the lowest cost option. However, it is also inherently biased, since the probability of being selected depends on the cost of observing you. Does this mean that such samples are necessarily invalid and unrepresentative? Well, it depends on what your goal is. If you have a good reason to believe that your convenience sample is at least somewhat random for the dimension you're measuring, then this might be okay. It's also true that convenience samples have some level of information, that they tell you that something is possible at least. Though we do have to be very cautious about inferring from such samples to broader populations that would include those less convenient observations. In fact, you could say that thanks to psychology professors using their students as subjects, we know a lot about the psychology of college students that take psychology classes, but we might not know very much about the psychology of anybody else. Let's go back to the university's problem. How might it sample its students' opinions about dining services? Now, one way of implementing a simple random sample would be to randomly select a number of student ID numbers, and then we contact those students, we have them take the survey. This would be pretty easy to implement, but it also might mean that we have staff spending significant time on the phone contacting each of these students individually. A systematic sample could be gathered lots of ways. One of those would be during the class registration process. Just randomly select one of those first 10 students to register to take the survey, then select every 10th student after that. Because it's unlikely that every 10th student will have shared opinions about dining services, this will probably be a representative sample, and it saves costs by being a systematic sample since the students are already interacting with the university. Now, for a stratified sample, we would divide the student body into groups that we want to make sure get represented. For example, we might divide by expected graduation year, and then we sample from each of those in proportion to the size of that group. Now, this would ensure that we don't accidentally over or underrepresent first semester students or last semester students. On the other hand, this could be tricky to implement. In cost terms, it ends up looking a lot like the simple random sample, but it has an extra layer of filtering before we make the sample. Now, for a cluster sample, we could just select a few classes to survey. This would be easy to do. Just contact a few professors, see if you can get into their classes, though that process might introduce some problems if professors refuse. But as long as that isn't too much of a problem, this would be pretty low cost. It requires much less staff time than calling students individually like the simple random sample would require. However, this could run into issues if the students in the selected classes have similar traits. So we could end up accidentally overrepresenting some groups and underrepresenting others, unless we have a sufficiently large number of clusters that we've selected. Now, one way to do a convenience sample would be to have somebody stand outside one of the main academic buildings and just survey students as they walk out. This is pretty easy to do. That is to say, it is actually convenient, as we would hope from convenience sampling, but it also could be biased. After all, students that don't use this particular building are immediately excluded. However, that problem might not be huge. We could make it less by doing two things. One, we could select the building and the time of day randomly. So Basically, we're adding in elements of cluster sampling. Right? And we could make sure that the building that's selected probably has no connection to the student's experience when we're surveying them about, in this case, dining. Right? So if we select, say, a building with a lot of gen ed requirements being taught in it, that's probably going to result in a more representative sample than if we select the culinary arts building. Now, when the university makes the choice of which sampling method to use, it will want to consider both the cost or ease of implementing that method and whether the method is likely to result in a sample that is actually representative of the student population.